Hi, my name is Femi and I'll be doing the basic question for the criteria chapters 3 and 4. So it says that Professor Moore's times in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool are as shown. So I already plugged this into my calculator, as you can see here. For L1 is my x value, L2 is my y value. So it says state the equation of the linear model. So all you would have to do is go to Stat Calc 8. Make sure your X list is your X value. For me, that's L1. And your Y list is your Y value. For me, that's L2. Calculate that. And boom. That's your regression line. B. The next day's time is 34.3 minutes. Predict the professor's pulse rate. Okay, so all you have to do is, as I wrote here, so your X value is your time and your Y value is your pulse. So all you have to do is plug in 34.3 for the X and just solve, which gives you 147.563. Since you can't have like half a pulse rate or half a heartbeat, which is kind of weird, you would just round that up to 148. C. Suppose you were told only that the pulse rate was 152. You now want to predict the swimming time. Find the equation of the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? Okay. So in statistics, you can predict a y value from a given x value, but you can't really predict an x value from a given y value. So what you would have to do in this case is, since it gives us the y value, is go to your calculator, Stat Calc 8, and for your X list, put in L2, or your Y values, and for the Y list, put in L1, or your X values. The reason we do this is because since it gives us the pulse, that would be an explanatory variable, which would mean that it's the X. So don't get confused, just switch the L2 and L1 or the X and Y list. And you would get a new regression line, which would be y hat equals 43.1 minus 0.06 times x. Okay, it gave us that the pulse rate was 152, so we just put 152 because in this regression line, the x is the pulse and the y is the time. Okay. So, when you put that in, you get 43.1 minus 0.06 times 152, which equals y hat value of 33.98. And if that bothers you, you can just say that that's about 34 minutes. Don't forget the units. Okay. D. Explain clearly to someone who knows no statistics why there are two different regression lines. Okay. So you can say this. There's always a x, y, a log of x and y, and an x and a log of y. So this graph would be something like, let's say, if it was just the x and y, this would be exponential, so it would be something like that. This one would be the opposite, which would be like that. And x and y is just plain old x and y. So our normal regression line, which you would go do from here, remember to switch to L1 and L2 again. So this shows us that the r squared value is 0.56%, which is not a lot. So to find the most appropriate line for this would be to go to Stat, Calc, and then do each one of these right here. Natural log, do that. Okay, so ln equals 0.56%. Go down. Exponential equals 0.55%. And last but not least, power. Ooh, and power is log of x and log of y. Our power here is 0.55, which all of these are 55%. Ooh, let's cross these out, that would be wrong. 56%, 56%, 55%. So the best regression line would be just to keep the normal one. So if you were to clearly explain to someone that knows no statistics, you would say for C, when you got the second regression line up here, okay, so this one would be if the x value is the pulse, and this one, if the x value is the time. And these two equations aren't equal to each other. So you just say to them that for different x values you get different y values. Just to keep it simple with them, because if they don't take statistics, they're not awesome and they won't understand all the cool terms that we use in statistics class. Thank you very much.